Today we will create few circuits. Here you see there are two circuits here. One is a common incomer, main incoming panel with a 415 volt incoming supply. Here we are getting. There is a circuit breaker ACB. ACB is air circuit breaker, and RIB indications are there in the incoming side of the ACB, and CT, that is current transformer, through which we are measuring the current flowing in the circuit through an ammeter, and ASS is nothing but an ammeter selector switch just to see the current between phase. And again here is one voltmeter that is again connected through a voltage selector switch VSS, and it is protected by 3 fuses. This 101, that is, you forgot about that is basically the tag name which I follow, because when I create schematic diagrams, these are called single line diagrams. Okay, when I create this schematic detailed wiring diagram, these circuits will come under sheet number 101. In this project I will create a sheet called E101. So in that particular sheet you can see all these wiring diagram, power distribution, because in a lineup, basically in panel lineups, there may be many panels. This is one of the incomer panel, and see the other is a drive panel. Drive is nothing, just like a starter. We use this. Using this you can control the speed, torque very accurately. This drive, incoming side of this drive, this is protected through an MCCB, molded case circuit breaker, and there is a line reactor, line choke, LCH, line choke in the incoming side of the drive, and this is a drive, and which is driving a motor of so and so kilowatt. This is encoder feedback, speed feedback, and these are the few MCBs which I am using for panel lighting, panel cooling fan, etc. Okay, so this is one panel and this is another panel. It is just like this. If you see the physical layout of this panel, the main incoming supply is coming from bottom. In this case, it is connected to the ACB, and through the ACB, this is flowing through a bus bar throughout the panel. Now here I have shown only 3 panels. There can be many, even 10, 15, 20. Okay, so if you see the second panel, this one drive panel, this is one panel. There I have installed a drive, and this is isolated through an MCCB, and the output will go through the bottom to the field wherever the motor is installed. This is the basic concept. This is another drive, and there can be many. This is what I represented through this single line diagram. The main supply is coming here. This is the ACB, and these are the indications which you normally see on the doors. RIB, whether the supply is coming or not, all the 3 phases are coming or not, then only you can switch on the ACB. So these are voltmeter, ammeter, current, and this will go to, if you see, this will go to the interpanel bus bars, and from there, from those bus bars, we will tap 3-phase supply through an MCCB and line reactor to the drive, and the output side of this drive will be terminated inside the panel, so that the cables from field, from the motor, can be drawn into the panel and will terminate this terminal. This is the outgoing side. In this case, I have assumed that this particular drive have both the incoming and outgoing terminals on the bottom side. Okay, so incoming supply is given to the terminals, input terminals of the drive, and the output as terminated here, and it will go out. Now what I am going to do is, I will show you how I draw the detailed wiring diagram. This is simple single line diagram. Okay, you cannot put any wire number here because you can see only one line here. In fact, there are three phases coming. See, this three line represents three phases. Three phases coming here, and you have to put some wire numbers there. And there are many controls. You cannot represent all this through single line diagram. This will give you the overall idea of what a circuit looks like. That's all. So many cases, what do you know? When you get a project and all, you don't have sufficient time. You may not get sufficient time to prepare a detailed wiring diagram. So what people normally do is they prepare a proposed power distribution scheme. You can call it single line diagram. This is how it looks like. We will get your supply from customer side and we will connect it through the ACB, and the rating will be this, and it will be connected like this. This is single line diagram. Simultaneously, I also prepare a panel layout like this, not like this, with the exact dimensions and all, and it will look like this. So once the customer approve this, we will go. Once the customer approve the number of panels, the distribution methodology, and the ratings of switches and all, then we prepare the schematic diagram, that is detailed wiring diagram. So that will be final. Otherwise, what happens is if you start preparing the schematic diagram initially, if the customer may ask you for any changes, it will consume a lot of time to rework on this. So once this is through, you can blindly follow this single line diagram. You just convert it into three line diagram. So now today we will learn how we can draw three line diagram of these two circuits. First this incomer and this drive panel. Again, this is one of the methods which I am going to show you. You can draw it in many ways. I use a different method, but here I am going to show you, considering you as a beginner in Autocad Electrical. There are many easy methods, but I will show you the simplest one. This is my title block. Okay, here I am going to draw a wiring diagram. So first of all, I have to draw three-phase supply. Okay, you can go back here. This is three-phase supply coming from customer side, right? So I am converting this into three line. I will draw empty space, go horizontal, 3 phase supply like this. Fine. So here I want to connect 3 fuses in order to connect RAB indication lamps. Again, going back to the bus, empty bus, go horizontal, go vertical. Another bus, okay, fine, it is done. So here I will put 3 fuses. I will go to the components, insert menu, fuses, second fuse, first fuse, 3 phase fuse with the tags. Down. This sheet number is 1. Okay. 101. This is not necessary. You should also follow this tagging format. Component tags can be any format, but I will show you what I follow and you can follow your own. I am putting it as 101 F3. See, again, if I am putting all the descriptions, rating, manufacturer and all, it may take more time. So what I am trying to do here is I will not put so many data. Okay. So what is the drawback of that is I cannot extract the bill of material from this drawing. So if you need to extract the bill of material, you have to put all the details. I practice that way. I do it. But here it will take more time. So that's why I'm just skipping these steps. I'm not putting a manufacturer catalog number or anything else here. Installation code, nothing. Okay. I'm just putting the rating. That's all. 101 F123 2 ampere. Yes. I have inserted 3 fuse. Now going back to the first sheet. Now I want to put ROB indication lamps. Go to icon menu. Here you can see pilot lights, red standard or right. I'm going to put it as 101 H1. Okay. Now I'm going to insert pilot light yellow 101 H2. Okay. Now I am going to insert pilot light blue 101 H3. Fine. So I have inserted 3 indication lamps. It is not necessary you should put these colors only. In fact, I can put it otherwise also. See, if I go to pilot lights, suppose if I am picking the white one, put, okay, repeat, put, okay, repeat, okay, repeat. I can do it in this way also. And if I don't want this color to be appeared in this, just delete it. Delete it. It won't make any difference. Until unless you don't want to extract the bill of material from this, it doesn't make any difference. You can draw as you wish. Right? So the other end of this should be connected to ground. RAB indication, right? Normally I use a different directory or symbol directory. So I'm not quite used with this library. Okay, I have my own library. I have created my own library. So I have to look where it lies. So therefore, what I have done is all these components you can find it here. Anyway, but instead of wasting time, I have copied a circuit here so that I can use some components from here as well. I'm going to put it here. You don't do this way. As I mentioned in the earlier classes, these incoming circuits, these kind of circuits are standard. Once you make a standard drawing for an incomer, that is standard. Once you make a drawing for this particular drive, this is standard. Maybe you may have to change the ratings and all, that's all. Okay. So, take your own time. That will be better. Now I am going to insert a circuit breaker. Circuit breaker, motor control, circuit breaker, sorry. This is that circuit breakers here. I'm going to put a 3-pole motor circuit breaker here. Sorry, I want to put an ACB in fact. Circuit breaker. Where is that? Where is the circuit breaker? 3-phase circuit breaker, 3-pole motor, 3-phase circuit breaker. This symbol normally is for ACB. 3-phase down. 101 ACB 1. I'm just putting the rating, that's all. I don't remember what is the rating. I think okay. 1600. Sorry, now I have to change it to 1600 amps. 1600 amps. Yes, update. Now, if I don't want the first two to appear in the drawing, you can hide this first two. If you need only one, fine. This is okay. Now, I have drawn this ROB indications, the air circuit breaker. Now coming back, the CT part. There are 3 CTs. In single line diagram, it will show only one. We can show only one CT. See, it is written here CT 1 to 3, but we cannot represent it in a single line diagram 3 CTs. That's why it is called single line diagram. Now here I want to insert all the 3 CTs. Cities. Just a minute. Yeah, cities you can hear current transformer. You can see here. This is oh shit. 101 CT1 rating, by okay, repeat. Now you see here is some spacing problem is here. You can adjust that spacing with the scoot command. Okay. Anyhow, I'm not doing it now. 101 CT2. Again the same rating. You can copy that rating from there as well. 105, okay, repeat. Here I am going to put the third CT, 101 CT3. Okay. These are 3 CTs. Again, if you want to move the attributes little bit here and there, very well possible for better look. Now I have to draw few wires from this. You should very carefully observe how I draw wires and all. One side of the CTs will be shorted together. Another I'm taking till here. Here. These are the 3 CTs. Going back to the, now it is connected to a kWh meter, kilowatt hour meter too. So for kilowatt hour meter I will just draw a simple rectangle here. Using symbol builder you can build any symbols for this kWh meter, whatever things you require you can make symbols. Properties, layer, I'll change this layer. I'll bring it here, here, here. Now go back to schematic, wires. You have to connect all these things with the wires. Like this. This is nothing, a beautification. See, now for this kilowatt hour meter, I have simply drawn a rectangle. Okay, but this is not the right way. Here, instead of making a rectangle, you should make a symbol with the terminals. With the kilowatt hour meter, kWh meter, the make you use will be different from what I normally use. So depending upon the make, you have to create a symbols from the manual. You have to see what are the terminals which is to be connected to the CTs. That you have to see. You have to make a symbol, and you should insert that symbol. You should save those symbols which you make in a separate directory. From there you can browse and insert those terminals, those symbols into drawing, and you should always follow that way only. Now again, from this meter, again going back to instead of an ammeter selector switch, I am putting a simple rectangle here. I will write down here what it is. This is a kWh meter. Fine. And this is ammeter selector switch. Few symbols may not be available in the library, right? So if you need some symbols which you normally frequently use, then you should create a symbol for those. Now I need to connect a ammeter here. Done. Insert. Go to ammeter. I think you will find out miscellaneous. Where is miscellaneous? No, not in this. Miscellaneous. Here you will say instrumentation. There must be something called instrumentation. Yeah, it's here. Instrumentation, ammeter. Now I am going to put this ammeter here. This is my 101 A1 and the rating is 0 to 1600 ampere. Again, you have to fill up all these things. At least the descriptions and manufacturer's name, catalog number if you know catalog number, otherwise put the series. You know, there must be some series of components like for example 3RV, 3RT series for Siemens makes. So like that, put some series at least. Installation is this lineup. If it is a lineup 1, put lineup 1. Whatever, you put LUP1 or line 1. Anyway, I mean, you can put it as you wish. This is again installation code, the panel number, which panel it is. I use 01TT. If you want you use P1, you use P1. This is the rating. Now, this is done. I want to move this attribute up. Right. So, RIB indications we have drawn. CT, kilowatt hour meter, ammeter selector switch, voltmeter. Now we have to put 3 fuses here for the voltmeter. So I will again draw from another bus. I will draw like this. Right? And I want to put 3 fuses here. See, all these components on the right hand side you can see, these are recently used components. You can pick it from here. I'm going to put it here, down. This is my one of 4 to 6. 4 to 6 numbers. 4, 5, 6. Okay. 4, 5, 6. This should be like this. So it will look nice. All the faces in one line. And I'm going to copy this particular component. So this one from here to here. As this is my ammeter selector, so voltmeter selector switch. Voltmeter selector switch. This is not the wire. Voltmeter selector switch, that is there. Now I have to draw a wire to connect voltmeter. Insert instrumentation, go to instrumentation, there you will find out voltmeter, put it here, 01 V1, Voltage is 0 to 500 volt AC. Okay. Move attribute little bit. This can be fixed, right? All these things you don't have to repeat all the time. These can be aligned. I mean, when I insert the symbols, you see what happens is what the tag comes here. I am going to insert somewhere around 21. Okay, this 21. I am going to put this line 21. See, voltmeter 21. By default, it is coming here, but I adopt a different method to create drawings, tagging. Therefore, I am putting. In fact, this should also be 101, not 101. This is my sheet 01. Those all the prefix what I use here will be 101, 101, 101. See my sheet number 101, 101, 101. And in fact, this should also be 101 ASS1. This 101 KWH1. 101 BSS1. So everything will be with a prefix 101. So voltmeter is also through. Now you have to connect 3 phases to this. Nothing, some technical connection. This thing. You have to connect 3 phases to here. So I will move little bit here. I will draw the 3 supplies from this to this. If you go through the manual of this power meter or a KWH meter, you will find out these terminals. You can easily find out. Just go through the Google and you can find out which makes you are looking and just search for its details. You will get all the details. So using symbol builder, I can very easily build a symbol for this kilowatt hour meter, right? So this is my circuit now. Incoming supply, if I want, I can write down here. Incoming 415 volt AC, 50 Hertz. Supply. I will take this layer. And in fact, the customer gives you 415 volt supply. That should not directly come to the ACB. So you have to provide some terminals, right? The cable from the field should come and connect to the terminals. So terminals you will find here, terminal, round terminal, square terminal, one line components. So I am putting terminals here. Round terminal 101 T1 1. Okay, repeat. I provided 3 terminals here. So terminals you will find out some other good type of terminals. Terminals and connected. See here you can see a lot of terminals. In fact, I should have put one of this. Anyway, putting this you can even the terminal number also you will get here. If you see, I am putting 101. Any other terminal with the terminal number. Let me put this number. So I am putting this thing 101 T1. Suppose it is T2, T21, okay, T22, okay, T3. That means with the tag 101 T2 there are 3 terminals. Like in this case, if you put these terminals here, it will be 101 T11, 101 T12, 101 T13. So this is what is called tagging. And this supply is going to the bus bar. This is in fact going to the bus bar. If I want, I can put bus bars here, but instead of that, I'm just making. Let us assume this is our bus bar. These are the 3 bus bars which is running through. Even the bus bar symbol is also available in this library, right? But I'm not using that. You should put those bus bar terminals, bus bar symbols. These are the 3 bus bars which is running throughout the panel. If you want, you can write it here, inter panel bus bar R phase, Y phase, B phase. You can write it here. Phase bus. This is this. This one. Y. And this one is my B phase. So my incomer portion is through. Fine. This is what my incomer circuit is all about. And of course, if the ACB is of with some control, I mean some extra accessories like under voltage relay or shunt trip, then of course those portions also you have to incorporate. You can incorporate in this sheet. Under voltage coil you can show here. Controlling this under voltage coil and all that you can show in this sheet. Fine. So this is my 101 sheet. I will make sure in my drawing properties the sheet number is 101, right? Now I want to tap 3 wires from this 3 bus bar to my next panel. Physically, I mean, we cannot show like a bus bar throughout see, if you see the layout, these 3, this is running throughout the panel. Okay, so that is what I am represented here as a bus bar. If you want to show it in all the drawings, that is also very well possible. Instead of this putting this bus bar, it will continue. This 3 lines will continue from one sheet to other, then next, and so on. That is also another way. Here I am putting a drawing taking 2 wires from here. But I am showing you in this way just because it will give you how to put source, destination arrow and all. I know this particular 3 wires will go to my next sheet, that is 102. That is this drive panel 102, because I have already prepared my single line diagram. I know it is going to 102. So in that case, what I do is I will put here source arrow 102 R1. Fine. And for this I will put 10Y2 Y1. 102 V1. What it is asking is, you see, this is asking insert matching destination arrow, because if I have the destination in this point in this drawing, I should have, if I pick OK, it will ask me to pick the other wire, but in fact I have not drawn the next wire, so I am clicking no. So this is my sheet 101 is all about. Now I will save this. These portions I don't want really, because okay, I will delete these portions. In fact, I will delete this too. This is my sheet 101. I'm going to save it as sheet 102. The first thing I do is I go to drawing properties and I will change my sheet property 102. Now I have added 102 in this drawing. Okay, but that is not appearing in this my project. So right click, add active drawing, right? So that will come here, 102. Now if you go back to the previous, you can see you will go to 101. Sorry. Yes. Now you see 102. This is 102. This is 101. You can move from one to another. This is my 102 sheet. Here we will draw the circuit for this drive. 101 is through. Now we will draw this particular. For that I need block of a drive. The drives, they are of they can be of ABB, Allen Bradley, Siemens, Toshiba, many Siemens. There are many makes. So depending on the drive which you use, you have to create a symbol. From the manual you have to see what are the terminals, what are the connection points, how it looks like, and the more detail you show, that drawing will look nice. So here I have made a block that is of a, I think that is of Allen Bradley. Yeah, I think it is Allen Bradley make. This is one drive, that block. This is my 102 DRV1. Whatever details you have, you can put. Any details. Ratings, drive size, unit rating, anything. So I am not putting any rating now. Fine. Manufacturer. These all things you have to take care while making this symbol. Using symbol builder. I am putting OK. This is my 102 driver. This is a block which I made using symbol builder. In this P line and all. While making the symbol builder, take your own time. Make it in a fantastic way. Beautiful look. Give it a beautiful look. Because we are not going to make it every time. This is a one-time job. The terminal numbers, all things you can insert. Now I want to connect 3-phase supply into the input terminals of this. That is RSTR, the 3 input terminals of this particular drive. So what I will do is, I will see there is option component. Okay, you can draw 3-phase wire from a component. Select the window. You see window can select kar do. Enter mar do. I select it. Just like staying this way. Drawn. Fine. See, now I have used another way of I used another way of drawing 3-phase line, 3-phase wire from a component. Another bus I have used, MG space I have. This is nothing, MG space horizontal and vertical. So 3 methods basically. See, now this is coming from the previous sheet. Okay. There we have already given the tags as for source arrow. There we inserted source arrow. See, yes, go back to that previous sheet. Here, these three supplies are going to be connected to that. Here we have allocated the codes as 102R1, 102Y1, 102V1. These are source arrows. In the next sheet, we will provide destination arrows, not source arrow, destination arrow. 102R1, the same code. 102Y1, 102B1. Forgot about this question marks, that will get updated later. So we have connected these 3 to that bus bar. Fine. Now there is a choke, input reactor. I have another symbol for that. Reactor, open. 102 LCH1. I'm not putting any rating, millihenry, microhenry, nothing. Simple. I'm not putting in the rating here. Few things, unnecessary things are here which I don't want. Hide. I am going to hide this thing, this thing, this thing. I want only one tag here. I don't want anything. This dashed line. If you want to insert and link components with a dashed line, you can. This is one component, so I cannot. If you want to link two components, you can very well link between two components using this dashed link lines. What is that? This thing. Link components with the dashed line. So it is here. Now I want to connect it to a motor. Fine. Again, component. Okay. Just take this terminals inside a window, enter, and take it through. Here. Now I want to insert a motor. Go to motor, motors, motor control. Yeah, 3-phase motor. I'm going to insert it here. That is 102 M1, my motor. Okay. Beautiful. Wow, I missed to insert a circuit breaker before this line shop. Fine, I will do that also. Insert circuit breaker. That's a molded case circuit breaker. This symbol. See the symbol. Yeah. While making the single line diagram and wiring diagram, you should keep in mind the standard which you like to follow. These are IEC standards. Sorry, NEMA standards. In IEC, if you want to make the drawings in IEC, it will be slightly different. The symbol, the representation will be slightly different. And while making the schematic diagram, also this is, if you see the flow, I am drawing it from left to right. The flow is from left to right. This is how we make drawings in NEMA. If you are making the drawings in IEC, it should coming from top to bottom. Top to bottom. Everything should be from top to bottom. But in this case, it is from left to right. This is the difference, basic difference of standard in between IEC and NEMA. Okay, so I am putting this. This is a MCCB. I am putting it here, and this is 102 MCCB1. Fine. 102. If I want to put the current, suppose 125 ampere, I put it here. Fine. Wow. If you want to hide something, you hide it. This is true. Now we have made two drawings. One is of this incomer and another of this particular drive. This is what we have shown is only the power. I mean, like this. All these drives comes with a IO card, input output cards. There you can write where the start push button, stop push button, fault reset push button, everything. So for that also you have to create a card with the terminal numbers. Then you can create the circuit as you like. So now if I do the wire numbering, I am going to do. See now this question mark is here. There is no wire number. It is question mark. Fine. If I do the wire number, project wide, I am going to do the wire number. There are only two sheets. I am going to do all. Okay. Now you see. देखा? ये 101 से आ रहा है. ये ferrule. This ferrule number. Note down. 10121. Last two digits you note down. 21, 41 and 63. This thing you will find in the first sheet. Actually, in fact, see these ferrules are placed here because I have drawn these bus bars with wire, layer wire. You should insert a bus bar symbol here, not should wire, because this program Autocad, you know how it writes the wire number. It starts reading from top here, from left, top left. It starts reading from here. ऐसे ही नीचे की तरफ पढ़ के आता है. तो जो यहाँ पर सबसे पहले ये पढ़ा इसने. Although this is the same wire from ACB, इस point से outgoing side of this ACB to all this is one wire, but ये प्रोग्राम पहले ये पॉइंट पकड़ा सबसे टॉप में. So that is why it is written 2-1. If you see 1 0 1 2 1, this is 2. Sheet 1 0 1 and 2 1. So if I want to move this wire number here, I will place it here. See 1 0 1 2 1 4 1 6 3. It is going to 1 0 2 4. And that's it. Yeah? This is how you can create distribution diagrams or schematic diagrams from single line diagram using single line diagram. This is only about an incomer and a drive panel. The next session I will demonstrate you how to make a complicated control diagram with a auto manual changeover switch, okay, and a connection from PLC and from panel. So there we have to use so many relays that will give you clear idea about how to do the cross referencing, how to insert ladders and many things. So next session we will cover that. Till then, bye.